What's the vocab word tied to this particular proof? So then what reasoning? Do you need to pause and maybe look for that on your own before we just start going through this? Supplementary. Is there a theorem? There is a supplement theorem, but the conditions are when we have a linear pair. Here, the conditions are their supplementary, and that one is just definition of supplementary angles. There's something we know about supplementary angles that allows us to make a conclusion just knowing that. So what does it mean to be supplementary? Again, if you want to pause and go look for it on your own, you can. But otherwise, I'm just going to tell you, measure of angle 3 plus measure of angle 4 will add up to 180. If they're supplementary, their measures equal 180. So the law of attachment says if you know it satisfies the conditions, make the conclusion. So here we go. The conclusion is they add up to 180, so I made that conclusion with angle 3 and angle 4. Actually, the other thing so that's the first thing they gave me. The second thing they gave me is an equation. So I already have 2. And then looking at my picture, we might be able to say that 1 and 2 form a linear pair. Maybe measure angle 1 plus measure angle 2 is going to be 180. But before I go and do all that, maybe check to see if I can replace something. 3 is there a couple times, so if we solve for 3, maybe we could replace it. But 180 is also there a couple times, and it's already set equal to both sums. So pick one of those equations. It doesn't really matter which one. It might save us a step or two depending on which one we do. I want 1 on the left side and 4 on the right side if you look at what we're trying to prove when we're finished. So maybe you want to do, let's see, which one has a 1 in it? The first sum. So maybe I'll start with that one. Measure of angle 3 plus measure of angle 1 equals 180. But wait, I'm not just going to rewrite that. We don't need to do that. We already know that. I am erasing, so scratching that off, and I can literally just erase the 180 and replace it if I want to with what else equals 180? Measure of angle 3 plus measure of angle 4, replacement rule. And now I have an equation that relates 1 and 4 in the same statement, in the same relationship, in the same equation. Do you see how the 3's are on both sides? What are you going to do? You're canceling them, but really what's happening when you cancel something like that is you're subtracting 3 from both sides of your equation. Measure of angle 1 is left on the left side. Measure of angle 4 is left on the right side. Which postulate, theorem, definition allows us to do that? Again, pause if you need to and go look for it. What says you're looking for a theorem that says you can add or subtract something from both sides of an equation. In fact, we don't even have to show that. All we have to do is tell the theorem that justifies that we can add or subtract. We don't have to show all our algebra anymore when we're doing a geometric proof. Additive property of equality. Add or subtract something from both sides of an equation. You know what? If you had done a different replacement or replaced it in the second equation instead, you'd have the same thing we'd have anyways, except 4 and 1 would be switched. You have to use, do you know which property? Symmetric property, S_ype, to switch that. But I kind of looked ahead and knew I wanted 1 on the left, so I replaced in a different way so that I wouldn't have to do that. All I have to do yet is change angle 1 and angle 4 congruent instead of saying their measures are equal using the definition of congruent angles. But maybe you had to do symmetric property first. Maybe you said they're congruent and then you use S_ypc to switch it. But I can change it once I know their measures are equal, because to be congruent, you have to have all the measures equal, and for an angle there's only one. So if you show the one, that's all. And you can state the 2 congruent. So angle 1 is congruent to angle 4.